Good evening, everybody. As promised, I'm going to be doing a walkthrough of all of the odds and all of the, what's up, Cleo? All of the odds and all of the proofs on the review. I'm also going to be going over the paragraph proof as well as 14 through 17 on 2-6. The reason is that things like that are going to be showing up on the test. So it's important that you guys know how to do them. That, and in general, I think that being able to go from words to equations is important, more so, or at least at this point early on in the year in geometry, realizing that those are going to pop up. So, here we go. So we're going to start off with number 1. So, number 1 is find a counterexample for each statement. Okay, so remember that when we're dealing with a counterexample, we want to treat the statement like a conditional. Conditional, again, is an if-then statement. So, hold on, yawn. Okay, that's over. So, a counterexample is something where we assume the if to be true, but we give an example where the then isn't true. So if it's an apple, then it's a red fruit. Well, all we have to do is prove that there could be an apple which isn't red. So we can put a green apple. Or Granny Smith, you can put Yellow Delicious, you can put a Pink Lady, even though I don't necessarily know that anyone's going to really bicker about pink or red. Anyway, all you have to do is say that there are apples out there which aren't red, and you've provided a counterexample which renders that statement false. So secondly, I'm going to go ahead and do 4 too. Mainly because there's some vocab here that you guys aren't used to. A parallelogram is a quadrilateral, that means something with 4 sides, which both sets of sides are parallel. So it has 4 congruent sides, then it's a square. So that's what we're sitting here. So what we're going to do is we're going to assume that first part to be true. A parallel with 4 congruent sides, and we need to figure out one that isn't a square. So what we're basically going to do is we're going to take a square, which is a parallelogram. See the little markings it's got, and we're going to take that top edge and we're going to kind of shift it to the left. Now this doesn't make the sides any longer. This just means that it is no longer 4 90-degree angles. And so what this is called is a rhombus. Now, some people I've seen putting down the word diamond, and that's fine. But in general, the reason I did this was because a lot of you guys don't know the term for rhombus or for parallelogram. So, number 5. So, for number 5, we're given a conditional. Now remember, a conditional has a hypothesis and a conclusion. So it's that if-then part. And then, so again, I'm going to color code it. The hypothesis is red. The conclusion is blue. So we're then asked to write the converse, inverse, and contrapositive for each true statement. Determine the truth value for each. So we're already told right off the bat that the hypothesis is true. So our conditional is if P then Q, and that's how we'd write it. So now, because let's say we're unsure what exactly a converse is, well, we go and look at our notes, and we see that the converse is if Q, then P. So the converse is basically us sitting there and switching the hypothesis and the conditional, or the hypothesis and the conclusion. So now we're going to go, the converse is if Q then P. So instead of saying if red then blue, we're going to go if blue then red. If a polygon has exactly 3 sides, then it is a triangle. Okay, now we're going to come back and we're going to worry about the truth of that statement later. This is really important. A lot of people get hung up on the truth value of the converse, inverse, and contrapositive. Now I want to make it clear that just because a conditional is true does not mean that all the other 3 variations of it also have to be true. That's what the truth value is there for. And so we can sit there and, so make sure that when you're doing the converse, the inverse, and the contrapositive, what you're really doing is just following the rules. You don't need to worry about the truth statement, or the truth value of the statement until afterwards. So, next up is the inverse. Sorry, I am super yawny tonight. Like yawning, not Yanni, the guy who does the, New Age music. So, inverse. If not P, then not Q. So if not red, so all we're going to do is we're going to negate the hypothesis, and then we're going to say then, and we're going to negate the conclusion. If a polygon is not a triangle, that's the negation of P, then it does not have exactly 3 sides. Okay? And that's that. So now we're going to do the contrapositive, which again, just fun to say. And that is if not Q, then not P. So if not blue, then not red. So we're going to start off with negating the conclusion. If a polygon does not have exactly 3 sides, then it is not a triangle. And being that the definition of a triangle is a polygon with exactly 3 sides, the converse is true, the inverse is true, and the contrapositive is true. So technically, we could do this as a biconditional, a true biconditional, and we could sit there and we could say a polygon is a triangle if and only if it has exactly 3 sides. And that's my bird playing with his new toy, Amir. He's quite a narcissistic bird. So my wife bought him a mirror, and he just sits there and kisses himself in the mirror. Because that's what you care about, and that's why you decided to watch this video, to find out about whether or not my bird was kissing himself in the mirror. Well, enough of that. Let's go on. So 7, 8, and 9, what we're talking about is a good definition here. Now, a good definition can be written as a true biconditional. Now, a true biconditional means that we have a true conditional and a true converse. Okay, so what we need to do is we need to basically write each one of these statements as a conditional, make sure it's true, and then write its converse. And if both the converse is true and the conditional is true, then it is going to be a good definition. So, a square has exactly 4 right angles. So we're going to say if a figure has exactly 4 right angles, we're going to write the Converse. If a figure has exactly 4 right angles, then it is a square. So what we need to do in order to figure out, remember, in geometry and mathematics, something is either always true or it's false. So all we have to do is come up with one example of something that has 4 right angles but isn't a square, and we'll prove that false. Okay, so if there's a counterexample, then it's false. So a counterexample here would be a rectangle. A rectangle has 4 right angles but is not a square. Okay? So the converse is false, so it is not a good definition. Now again, if you're watching this, let's say you only needed help on number 14. Okay? What you want to do is just go ahead, fast forward to that point, watch that. You don't need to watch, me talking about my bird kissing himself in the mirror. You can just fast forward. Also, if these don't make sense to you, go ahead, rewatch it. So, on to number 9. So, horses are animals with 4 legs. That's true. If an animal's a horse, then it has 4 legs. Okay? Normally, now clearly there are examples of 3-legged horses and such, but they're pretty rare, and in general, a horse has 4 legs. So what we're going to do is we're going to write the the converse of that. If an animal has 4 legs, then it is a horse. This is clearly wrong. Dogs, cats, rabbits, any quadruped. So that's false, so it's not a good definition. Okay, again, a good definition, go back to the last slide. A good definition can be written as a true biconditional. A true biconditional has a true condition. The conditional is true and the converse is true. So, now we're going to look at 15 and 17 here. We're going to name the property that justifies each statement. So on 15, we know it's a property of equality. How do we know that? Because they're equal signs. If there were congruent signs, we'd write POC for property of equality. Brea, off. Brea, off. Brea, off. Brea, off the couch. Sorry. We let our dogs on the couch, but she's having a bit of an allergy attack, and scratching, and I don't want her ripping the couch. So, 15, property of equality. And it is the transitive property of equality. And we know it's the transitive property of equality because when we sit there, what I want you to do on these is sit there with your binder open, sit there on the page of notes that I made you take, that I signed off on your belt work that you took, where you wrote down all the properties of equality that were on the board and all the properties of congruence that were on the board. And you'll see one that says if A equals B, then B equals C. Or if A equals B and B equals C, then A equals C. Here we have 2 distances. A and B is equal to the distance from C to D. C to D is equal to the distance from E to F. So we're going to cut out the middleman, and we get the distance from A to B is equal to the distance from E to F. And that cutting out the middleman, that's kind of the hallmark of the transitive property. 2 things are equal to the same thing, therefore they are equal to each other. So, transitive property of equality would be number 15. Let's look at number 17. So again, equals, equals, equals. So we have a property of equality. And this one's just going to be substitution. Why is this one substitution? The other one was transitive. Notice we're taking out the middleman here. Here there's no real middleman, sorry. Here there's no real middleman. We're saying if x equals 18, then y equals 18, okay? So we start off with x equals y. If x equals 18, we know x and y are the same, so we switch out the x for the y. Okay, and the way it's set up, the way it's stated, makes this a substitution issue, not a transitive issue. Even though in cases like this where it's 1-to-1, they're almost interchangeable, but I want you to think of transitive properties, that kind of cutting out the middleman. If A equals B and B equals C, then we can cut out the B and we get A equals C. Okay, 19. So we need to find the value of each variable. Now when we look at this, we see that they're vertical angles. Now vertical angles are kind of a hallmark of this chapter. So if we have an angle right there, and then we draw the opposite rays for that angle, the resulting angle right there is vertical. And we know from our vertical angle theorem that vertical angles are congruent. Congruent angles have equal measures. So we're going to go 3x minus 63 equals x plus 37. Subtract x from both sides, and we get 2x minus 63 equals 37. Add 63, we get 2x equals 100, or x equals 50. Now, I apparently go ahead and figure out that that means the angles are 87, but being that all we had to do is find the value of the variable, that was unnecessary. So, let's keep moving. Measure 1 using the given information. Now here on number 7, we're given 1 and 4. We know 1 and 4 are vertical angles, which means they're congruent. So we can go 5x equals 2x plus 90. Congruent angles have equal measures. That means if we're given the value of two vertical angles, we can set them equal to each other. We're going to subtract 2x from both sides. That gives us 3x equals 90. Divide by 3, and we get x equals 30. We're not done yet. We have to go back, plug in, since we're looking for the measure of angle 1, that's what we have to do on all three of these problems. Measure of angle 1 equals 5 times x equals 30, so the measure of angle 1 equals 5 times 30, or 150 degrees. So, things get a little bit trickier with number 9. We have 2 and 3 here, okay? Now the thing is we know that 2 and 3 are vertical, which means they're congruent. And that also means they're both supplementary to angle 1. Remember, supplementary means their measures add up to 180. So we first need to figure out the values of 2 and 3, and then we can figure out the value of angle 1. So we know that measure 2 equals measure 3, or that 180 minus 3x, that's measure of angle 2, equals 2x, that's the measure of angle 3. We're going to add 3x to both sides, and we're going to get 180 equals 5x. We're going to divide both sides by 5, and we get x equals 36. Now, first things first, we need to use that 36 to figure out the measure of angle 2 and angle 3. Measure of angle 2 equals 2x. That's actually the measure of angle 3. See, I put it into 3. So x equals 36, so the measure of angle 3 equals 2 times 36, or the measure of angle 3 equals 72 degrees. Since we know that that's 72, we know that the measure of angle 1 plus the measure of angle 3 equals 180 degrees. That gives us the measure of angle 1 plus 72 degrees equals 180. Subtract 72 from both sides, and we get the measure of angle 1 equals 108. I know it's a lot of work, but there you go. Moving on. Whew, yay, proofs. Okay, so here we are given that the measure, or that angle A is congruent to angle BDA. So when the reason given in statement 1 that says given, we're just going to write down what we're given. Easy peasy. So next, going down to 2, it says vertical angles are congruent. So let's look over at our diagram. We see the only pair of vertical angles there, BDA and CDE. Since we know that the justification for setting is that vertical angles are congruent, we can assume that the statement is that the two angles, we're setting two angles congruent to each other, and that those two angles are vertical angles. Since they're the only vertical angles we have, we can go BDA is congruent to CDE. So the next one, the step we're given, or the statement we're given, is angle A equals CDE. So what we're going to do is we're going to look at 1 and 2 and see how we put those two together to get 3. Now we see there's that kind of middleman thing. A is congruent to BDA, BDA is congruent to CDE. So we can get rid of the middleman and say A is congruent to CDE, and that is the transitive property of congruence. So next step for the justification is the definition of congruence. Well, the definition of congruence is that congruent angles have equal measures. We look at the step right above us. We see that we're talking about two angles which are congruent. So we should be able to make the assumption that we're just simply taking those two congruent angles and saying that their measures are equal, because that's the definition of congruence. Again, if you're not sitting there on a proof with your notebook open to the vocab and the rules section of your notebook, you are not being fair to yourself. Because I don't expect you guys to sit there and have memorized every single postulate, every single rule, every single theorem, and on top of that, just be able to call them up right away. So when you sit down and do a proof, you need to make sure that you have that information handy. That's why I give it to you. So, next step, we're switching out angle A and angle CDE for their given measures. So that's just substitution, or as some people like to call it, the switcheroo property. So next we have subtraction property of equality. Well, we know we're starting with this. So there are actually two different ways you could go. I'm going to subtract 11x first, but you can also subtract 15 from both sides. So I'm going to get 20 equals x plus 15. Okay, so now when we're sitting here looking at that last step, notice that both the step and the justification are blank. So this really, this is something I want to kind of drill into you guys, that the last step of a proof should always be what we're trying to prove. So here we're trying to prove x equals 5. So we should be able to just go ahead and plug in x equals 5 there. So notice we're looking at step 6, 20 equals x plus 15. Step 7 is x equals 5. How do we get there? Well, we go ahead and we subtract 15 from both sides. What property allows us to do that? Subtraction property of equality. And we are done with that proof. 2/6. So, I don't know what happened when I printed this off, but for some reason it read those congruent signs as just less than or equal to signs. So given that 5 is congruent to 2, prove 8 is congruent to 4. So again, step 1 says we're given that those two angles are congruent, so we can just plug that in. Step 2, 2 is congruent to 4. Well, let's look at the relationship between 2 and 4. What do we have to say that those two are congruent? Well, we know they're vertical angles. Again, you need to be able to identify vertical angles. It is crucial to this chapter, and frankly, for a significant portion of the remaining ones. So we're going to put vertical angle theorem, because the vertical angle theorem says that vertical angles are congruent. Here we have 2 and 4 as vertical, So we say 2 and 4 are congruent. So next, the justification we're given is the transitive property of congruence. So what we want to do is we want to look at those first two, see that we have that kind of symmetry there. 5 is congruent to 2, 2 is congruent to 4. So we can say that 5 is congruent to 4, because that's that A is congruent to B is congruent to C. We'll cut out the middleman and make A congruent to C. So then we're looking for other vertical angles. Now here, choosing which ones to be vertical is a little tricky, but we're trying to prove that 8 and 4 are the same. Now we haven't done anything with 8 yet, so chances are that we're going to look at it and go, okay, well, how are we going to get from 5 is congruent to 4 to 8 is congruent to 4? Well, what if we can relate 8 and 5 to each other? How are 8 and 5 related? 8 and 5 are vertical. So we can sit there and go, 8 is congruent to 5 by the vertical angles theorem. Again, we now have 8 is congruent to 4, so we're going to look back up at 3 and 4. We're going to see those two 5s there. We're going to get rid of those 5s, and we're going to get, hey look, 8 is congruent to 4. And that again is the transitive property of congruence, or transitive POC. And we're done with that. Now, I know that said I'm just going to do odds, but I also said I want to do all the proofs. So 12 is a proof, so let's do the proof. We'll do it a little bit, sorry about that, more cohesively. So, we start off with our givens. 1 and 2 are complementary, 2 and 3 are complementary, and BD bisects ABC. So we need to prove that the measure of angle 1, which is out there floating in the air, is 45 degrees. So this is how we're going to do it. So let's look at that first sentence. We know that blank and blank are complementary and that 2 and 3 are complementary because these facts are given. Well, 2 and 3 are complementary is a given, and the only other blank we could fill that in is angle 1 and 2 are complementary. So the next sentence then says, by the blank, the measure of angle 2 plus the measure of angle 3 equals 90. So again, when we're looking at this, we're going to go, okay, well, if 2 and 3 are complementary, that means 2 and 3 are, the sum of their measures is 90. Well, that is just the definition of complementary angles. So a lot of times when we're switching from congruence to equality, or 1 and 2 are complementary to 1 plus 2 equals 90, those are just going to be our definitions. So, given that AB, so now we're looking at that next one. Given that BD bisects ABC, well, what does it mean? Bisects mean that we have two angles which are equal to each other. So we can set up that the measure of angle 2 equals the measure of angle 3. Using substitution, and this is a little tricky, but we can go 3 plus 3, whoopsie, equals 90. Okay? Now, how did we know that we're switching out for angle 2 instead of angle 3? Well, we look right there at the or. And we see that the or says or 2 times the measure of angle 3. That means somewhere we added an angle 3. We added m, the measure of angle 3, plus the measure of angle 3. Well, the only way to do that is to switch out the measure of angle 2 for the measure of angle 3. So there we go. So we now see that measure of angle 3 equals 45 degrees. So we went from 2 times the measure of angle 3 equals 90 to measure of angle 3 equals 45. So that is the division property of equality because we divided both sides by 2. By the congruent complements theorem, now the congruent complements theorem says that if two angles are complements of the same angle, then they are congruent. Well, if we look up at our givens, we see that 1 and 2 are complementary, and that 2 and 3 are complementary. Notice those 2's there. So we can skip the 2's and we can say that 1 and 3 are complementary. Or that 1 and 3 are congruent because they're both complementary to the same angle. So if we know that 3 equals 45 and 1 and 3 are congruent, it follows that the measure of angle 1 also equals angle 3. Okay? Because congruent angles have the same measure, and measure of angle 1 equals 45 by substitution. Again, what we're doing is we're switching out the 1 for the 45 there. And again, we know that our last step should always be our proven. Our proven is 1 equals 45, so that should be our last step. Okay, moving on. Next proof. Now again, here things got a little bit screwy. I don't know where those L's came from. It's just a formatting issue. So we have the measure of angle ACB plus the measure of BCE equals 180. Now here we don't have any givens. But we can look here and see that BCE and ACB are a linear pair. Linear pairs are supplementary. So we can go definition of linear pairs or definition of supplementary angles. Next, we sat there, we took that 5x and we plugged it in for ACB. And we took that 9x plus 40 and plugged it in for BCE. And that, my dear children, is substitution. Now notice in previous proofs, they'll put things like simplify. Here, when they add the 9x and the 5x to get 14x, they're calling it combined like terms. I'm going to be honest, either one works. So C we do nothing with. D, how do we go from 14x plus 40 equals 180 to 14x equals 140? Well, we subtracted 40 from both sides. So 40 minus 40 is 0. 0 plus 14x is 14x. And 180 minus 40 is 140. The subtraction property of equality is that property which allows us to subtract the same amount from both sides and keep it as an equality. Hey, Cleo. What's up? I know. Cleo wants to go to bed. So now we looked at it and we've only got one left. So again, don't know where those L's came from. But when we look at them, we see that BCE and ACD are vertical angles. How do we know that vertical angles are congruent? Well, that is the vertical angles theorem. And that is that. On to these last ones. So, these last ones are pretty straightforward. You're going to get 3 different types of problems on these last 2 pages. You're going to get vertical angles, in which B is equal to the given angle. You're going to get complementary angles, in which B plus the given angle equals 90. And you're going to get supplementary angles, which are linear pairs, in which B plus the given angle equals 180. So problem number 1, vertical angles. So we have B equals the given, B equals 64, and you're done. That's it. So even though it's not an odd, I'm going to do number 2. Here we have that right angle, so we know that they're complementary. So we know that B plus 38 equals 90. We're going to subtract 38 from both sides, and we get B equals 52. 52. Here, number 3, we have a linear pair, so they're going to be supplementary. So B plus 76 equals 180. Subtract 76 from both sides, and you get B equals 104. Down on number 5, we again have vertical angles. So you're going to get B equals 82. Number 7, vertical angles again. So B equals 85. degrees. 9, hey, more vertical angles, yay! B equals 76 degrees. 11 is a little bit different. We're back to a supplementary angle. Supplementary angles, we have 57 plus B equals 180 degrees. We're going to subtract 57 from both sides, and we get B equals 123. 13, last two. 13, we see that they are complementary. They add up to 90 degrees. So we're going to go 64 plus B equals 90. We are going to subtract 64 from both sides. And we are going to go that B equals 26 degrees. Finally, 15, supplementary angles, B plus 122 equals 180. Subtract 122 from both sides, and we get B equals 58 degrees. So this is the end of the chapter review. As I said, though, I'm going to do really quickly the proofs on, or the paragraph proof from 2.6, and then I'm going to work through 14 through 17. So here, when I'm looking at this, I say 1 and 4 because it is given, and then I'm asked to justify why 1 has to be congruent to angle 2. Well, if I look at angle 1 and angle 2, I see they're vertical angles. So I plug in the vertical angle theorem, because the vertical angle theorem says that vertical angles are congruent. Two is congruent to 4. Now here, what we're really saying here is if 4 is congruent to 2, or sorry, if 1 is congruent to 2, that's a 1, angle 1, not a 4, and angle 4 is congruent to angle 1, then angle 2 is congruent to angle 4. Again, we're crossing out the middlemen, and we're ending up with 2 is congruent to 4, and that is the transitive property of congruence. Why congruence? Because we look at the sign. If it was an equality sign, we'd be doing the transitive property of equality. Because it's a congruent sign, we're doing transitive property of congruence. So, now let's look at 3 and 4. Again, 3 and 4, it's just a repeat of what we did with 1 and 2. They are vertical angles, so we're going to say that it is right by the vertical angle theorem. So now we're going to look at, it follows that blank is congruent to blank. Again, you should be aware by now that when we are trying to prove something, that the last step is always going to be the prove step. Again, if we're trying to prove that 2 is congruent to 3, that should be our last step. Our last step should be proving that 2 is congruent to 3. If not, then you're just continuing for no reason. If you prove what you're trying to prove and keep going, that's just wasted effort. So let's plug in 2 is congruent to 3. And then how do we know that? And again, we look here. We see that 3 is congruent to 4. We see that 2 is congruent to 4. So we can cut out that middleman 4 and get 2 is congruent to 3. And that process is the transitive property of congruence. Now, I know I went over this in all the classes, but there were still some people who didn't understand it or weren't paying attention, so I figured I'd give you this again. Now, what I suggest you do is, to make your life easier, 14 through 17 all have measure of angle A and the measure of angle B being different. They're either congruent, they could be complementary, they could be supplementary, but you're given two things. Now, what you're really being asked to do here is set up a system of equations and then solve for x and y. Except instead of calling them x and y, we're calling them the measure of angle A and the measure of angle B. So, being that most of you guys are more comfortable with algebra than geometry, so you're more comfortable with x's and y's and the measure of angle A and the measure of angle B, I suggested that you guys just sit there and change those out. Say, let the measure of angle A equals x, and the measure of angle B equals y. So, in number 14, we see that they are complements of each other. That means they're complementary. That means that x plus y equals 90. We also now know that A is 3 times as large as its complement B. So we're going to go x is 3 times its complement, y. We're now going to substitute that 3y in for x. So we get 3y plus y equals 90 degrees. 4y equals 90 degrees. Divide both sides by 4. We get y equals 22.5. So we know that x and y are complements. That means they add up to 90 degrees. So that means that x plus 22.5 equals 90 degrees. We're going to subtract 22.5 from both sides. And we go x equals 67.5. So now we know that we remember that the measure of angle A equals x and the measure of angle B equals y. So we write down the measure of angle A instead of x equals 67.5, and the measure of angle y equals 22. The measure of angle B equals 22.5. So, moving on. These next one are supplements. So we're going to go x plus y equals 180 because they're supplementary angles. A is 21 less than twice as large. So those are, that is less than and twice as large. Those are our action statements. Those are the statements which directly refer to the standards that we have to teach, as well as the vocabulary words you should know. So, x is 21 less than. Now, a lot of people will end up putting 21 minus 2y, but it's really 2y minus 21. And the reason is, if I said, what's 6 less than 10? You guys would say 4. But if I said, what number is 6 less than 10? A lot of you guys would put n is 6 minus 10. So, that less than, 21 less than something else, means that that negative 21 goes on the back end. We're going to plug that in. We get 2y plus 21 plus y, or 2y minus 21 plus y equals 180. Combine like terms. We get 3y minus 21 equals 180. Use the subtraction property of equality, the addition property of equality. We're going to add 21 to both sides. We get 3y equals 201. Divide both sides by 3 and we get y equals 67. Now keep in mind, that's the measure of angle B. So to find the measure of angle A, we're going to remember that x plus y equal 180. We're going to substitute out the y for the 67. So we get x plus 67 equals 180. And then we subtract 67 from both sides. That's going to give us x equals 113 degrees. So, the measure of angle A, or x, equals 113 degrees, and the measure of angle B equals 67 degrees. So, I'm actually not going to work out this one. I'm just going to look at 16 and see that A and B are congruent supplements. And me being the person who actually wrote down all the terms and is familiar with them, I remember the congruent supplements theorem. It says if two angles are congruent and supplement to each other, then they are both right angles. So the measure of A equals 90 degrees and the measure of B equals 90 degrees. Now this last one I am going to switch over on. So again, we are told that these two angles are complements. X plus y equals 90. We then know that x is 18 more than 5 times its complement. So let's put down 5 times its complement, 5y, plus 18. Plug that in, because really what we're looking for is the measure of angle A, the measure of angle B. Right now those are being hidden under x's and y's. So we're going to write it out. 5y plus 18 plus y equals 90. 6y plus 18 equals 90. We are going to subtract 18 from both sides. So we get 6y equals 72. Divide both sides, we get y equals 12. So we're halfway there. What we're going to do is we're going to go x plus y equals 90, because they're complementary. Y equals 12, that means x plus 12 equals 90. So we get x equals 78. So the measure of angle A instead of x is 78 degrees. And the measure of angle B instead of y is 12 degrees. Read through this, look over it, rely on this, put together a question set based on what you didn't understand, but don't just sit there and let this test happen. Actively be prepared for it. And that's it. Have a good night.